This meeting is being recorded.
Fine. So today we'll start with projectile motion. This is two-dimensional motion, 2D motion. So in previous chapter we have studied about the one-dimensional motion, like on a straight line, that is known as rectilinear motion. And now we'll study about 2D motion, two-dimensional motion. So like we have axis, x and y axis. Suppose you throw a ball or any particle at some angle theta with the horizontal. You know that this ball will travel this path, right? It will come down and will strike the ground after at certain distance. So it comes down because of the gravitational force that keeps working on the object, right? Downward. Suppose we throw this ball with some velocity u at some angle theta, and from where you throw your ball, you can assume origin. So this can be considered as origin, 0, 0. So there are some terms we can define that u, that is initial velocity that we give, that is known as speed of projection. Speed of projection. Theta is known as angle of projection. And Earth will pull this particle downward by some force mg. So we can define acceleration as force upon mass, that is g. This is acceleration due to gravity. And you can see the initial angle between initial velocity, that is projection velocity, and the acceleration is always this 90 and plus this angle theta. So theta plus 90 is the angle between initial velocity u that we provide and the acceleration due to gravity, right? And this motion is known as, you can call it planar motion, because this happens in a plane, xy plane. And this distance from here to here, where it strikes the ground, is known as range. We denote it by r. R is called range. And this maximum height that it achieves is known as maximum height. Right. So these are the terminology that you have to note down. Note it down. And after throwing the ball, this ball will take some time to come from this point to this point, right? Time taken in the complete journey is known as time of flight. And because you can call it ground to ground projectile, because you throw the ball from ground and it comes back to the ground.
Sir, why theta plus 90?
Theta plus 90 is the angle between initial velocity that you give, that is known as the speed of projection, and acceleration due to gravity. This here, this thing. This angle, this is 90,
Okay.
and this angle is theta.
Okay, sir.
Aishu, what happened to your video?
Sir, it is taking time to switch on.
So how much time it will take? What is ETL?
Sir, I don't know. Sir, 1 minute.
Okay. Let me know when once done. You can raise your hand. So, Shaina, in your coaching class, this projectile motion is done or not?
Yeah, it's done, sir.
Fine. It would be good, like you can compare and you can find any gap. if
Yeah,
there is
yeah.
any. Is you done? Okay. You're still writing. Okay.
Yes, sir. Done.
Okay. Now you can see uh, this motion, this complete projectile motion can be you can break it down into two components because when you throw the ball from here, it will follow this path. This is known as parabolic path. I'll tell you the equation of trajectory as well later. So this is known as parabolic path. So you can break this motion into two component, one horizontal component and other vertical component. So one horizontal component along x-axis and other vertical component along y-axis at some angle. So there was a scientist, Galileo. He stated one very important thing. He said that motion in mutually perpendicular direction does not depend on the component of. You can state it like motion in two mutually perpendicular direction is independent of each other. Motion in mutually perpendicular direction is independent of each other. This is very important statement. Motion in two mutually perpendicular direction is independent to each other. What does this mean actually? It means that whatever motion is happening in x direction, it has nothing to do with the component that is acting along the y-axis. Like, suppose you can break down this velocity into two components like ux and uy. Initial velocity along y-axis and initial velocity along x-axis. So ux can be written as u cos theta, cos component of u, and ui can be written as u sin theta. So along x-axis, if you note down the components, so ux is u cos theta, and along y-axis you can note it down. You can write ui equal to u sin theta. And you can see that when you throw any ball, there is only one force acting, and that is because of the gravity. So acceleration acts downward only, right? Always. So you can write acceleration as g. So before that, you have to decide the sign. If you assume right side plus, then left side would be minus, and upward plus, then downward would be minus. You can assume either way. You can take upside as positive and downside as negative, or vice versa. So because now we have taken upside as positive, so downside would be minus. It would be minus g. And acceleration. This is 0. acceleration along x-axis is 0, acceleration along y-axis is minus c. See, acceleration is acting along y direction only. So this acceleration is not going to impact the component along x-axis. This is the meaning of this statement, right? Motion in two mutually perpendicular directions is independent to each other. So whatever component you have in y direction, that is not going to impact the motion along x direction, right? So suppose you have thrown this ball from here and this ball will come over here after some time. So it will have some other velocity, right? When you throw the ball with some initial velocity, it will go up to the maximum level and then it will come down. So during the motion, you throw the ball and it reaches the top point, its velocity keeps on decreasing, right? So suppose at certain point, its velocity is v, like this. So this v will again have two components. Suppose this angle with the horizontal is alpha. So this velocity will have two components like v cos alpha and v sin alpha. So suppose in case we have to find the velocity at certain time, how can we find? See, velocity along x-axis at a certain time is, we can write it as ux plus ax into t. We know the formula, v equal to u plus at. And because we are considering x-axis only, so we have to use x component only. And vy equal to uy plus ay into t. Now you can see that there is no acceleration along x-axis. So this component will become 0. So Vx will be equal to Ux. And Ux you had u cos theta only. So you can see one thing, in projectile motion, the horizontal component will remain constant at every time, right? And now Vy will be Uy. Uy is u sin theta and Ay is minus g into t. We can also find displacement at certain time along x-axis and y-axis. So Sx, we can write it as Sx. That would be Ux t plus half Ax t squared. So Ux is u cos theta into t, and there is no contribution of this term because Ax is 0. Sy is u sin theta plus half uy into t plus half ay into t squared. That would be u sin theta into t minus half gt squared.
Done, sir.
Everyone done? Going forward, when we will solve projectile motion question, we'll do one thing first. We'll divide it into two components. We'll first make the table. And we'll write all the component along x-axis and all the component along y-axis, and then we'll solve. Right? Done, na? Okay. What is time of ascent and descent? Can you tell, Prisha and Shaina, any one of you? What is time of ascent and descent?
Basically, from ground state to the highest point of the projectile is the time of ascent, and the descent is the highest point to the ground again.
So which one would be bigger? Like suppose T1
Would
is
it,
the time of ascent and T2 is the time of descent. So which one will be bigger?
they'll be the same, right?
Acha, right. See, this is x-axis, this is y-axis. Suppose you throw ball from here with some initial speed of projection at some angle theta with the horizontal. It will follow this path. See, it will keep going up, going up, going up, and at certain point, like it will reach the maximum point. So time taken from ground to the maximum point is known as time of ascent. Let's denote it by TA and TD, time of descent. So this time from here, O point to A point, this is the maximum point. So this time is known as time of ascent. So we have to find this time. And you know, at maximum point, what would be the vertical component of the velocity? Prisha?
0.
Acha, I use 0. Prisha,
Sir, can you repeat the question?
at a maximum point, what would be the vertical component of the velocity at this point?
Then that would be plus B, because
Sorry?
the angle would be
Prisha, come again.
Sir, am I audible?
How much? How much?
Sir, can you tell me, am I audible?
I can't understand you. What you were saying. Okay, fine. So at the maximum point, the vertical component of the velocity will be 0. So along this direction, the velocity, vertical component of the velocity will be 0, and the horizontal component would be same, u cos theta, because in the projectile, horizontal component of the velocity always remains constant. So now we have to find time of ascent. Now you can see here at initial point, the initial component was u sin theta. So you can apply this formula, Vy equal to Uy plus Ayt. So at this point, Vy is 0, Uy is U sin theta. In positive direction, I am taking up direction as positive and down direction as negative. And acceleration is, that is downward. So we'll take it as a negative into Ta. So Ta is U sin theta upon G. And remember one thing, in uniform accelerated motion, if acceleration is constant, then time time of ascent and time of descent will be same. If there is no air resistance or anything, in that case, time of descent will also be same, u sin theta upon G. So same amount of time will be taken from here to here and then here to ground again. So TD.
But it's a downward motion, so gravity is acting in favor. So why is it minus G?
Because I have taken upward as positive. So downward would be negative. You can
Okay.
take downward as positive. So upward would be negative. There won't be any difference in the answer.
Okay.
So see, if you take downward as positive and upward as negative, then your initial velocity will be negative, you see,
Oh, okay.
right now? So it will compensate. Yeah.
Yeah.
So total time of flight would be time of ascent plus time of descent. That would be u sin theta by G multiplied by twice, both are same. So you have to remember this thing. Total time of flight. We denote it by capital T, 2u sin theta by G. Or you can also write 2. What is u sin theta? That is initial component of the speed of projection, uy upon G.
Sir, here the time of ascent and the time of descent will only be equal if there is no resistance from the.
Because right now we are not considering any air resistance. So this is a uniformly accelerated motion, like, when ball goes up and comes down, in both the cases, like, gravity works and acceleration is only g downward. So acceleration is constant, right? So when acceleration is constant, so time taken to go up and time taken to come down will be same. Done, everyone? China, you're done?
Yes, sir.
Okay. Now we have to find maximum height. Do you remember the formula of maximum height? Anyone remember? So this height is known as maximum height achieved by a projectile uh, in a projectile motion. So how would you find this? So this is the displacement along y-axis, and we have taken upward direction as positive. So we'll apply this formula: y equal to ut plus half at squared. And we, as per the Galileo's statement, we can assume y direction independently. So the displacement along y-axis is how much? From here to here. This h only. So this is positive. So plus h equal to uy. Uy is u sine theta. U sine theta u sine theta into t plus half ay is minus z or into t square. So now this t is what? Time of ascent, na? Ta, time of ascent. So you can put time of the value of time of ascent, that is u sine theta upon g, if you remember. And if you don't remember, I'll tell you another way. U sine theta whole square upon g square. This gone, this gone. So this is u square sine square theta upon g minus u square sine square theta upon 2g. So you will get finally u square sine square theta upon 2g. So this is like y component of initial velocity ka whole square upon 2g. This is the maximum height achieved in a projectile motion. I'll tell you another way as well.
Sir, could you please scroll down?
Scroll down. There is nothing.
Yes, sir.
Let me know once done.
Done, sir.
Achha, okay, fine. Now we'll calculate range. Do you remember the formula of range? Anyone? How do you find range? This distance is known as range. From the
Is
point where
this
you throw the.
So
Yeah, tell
it's
me.
u cos theta into t.
Yes. This distance is known as a range,
Sx.
right? See, so this range can be found out like this. See, there is no acceleration along x-axis. So see, you can apply this formula, and later I'll tell you. Displacement along x-axis, that is ux into t plus half ax into t square. And there is no acceleration along x-axis, so this will be 0. And this displacement along x-axis is known as range. That is u cos theta. Ux is u cos theta into time taken in the complete motion. So time taken by this particle to come from here to here along this path would be same as the time taken to cover up this displacement. So this time taken is time of flight, and that is 2u sine theta upon g. So this would be u square, and you know the formula 2 sine theta cos theta. What is this? Sine 2 theta. This is the formula of range. You can remember this. You have to remember this actually. Or you can also write this in this term, like see, u cos theta, u sine theta upon g multiplied by 2. So this u cos theta is, it is x component of initial velocity. The u sine theta is y component of initial velocity upon g. 2 ux ui upon g. Note it down. Are you see done?
Yes, sir.
No, no, you are done. I am waiting for Prisha and Shaina.
Yeah, I'm done too. Sir.
Prisha,
Yes, sir.
you're also done?
Yes.
Okay, fine. See, so what is the formula of range that you got? U square sine 2 theta upon g. I want to find the maximum value of the range. So suppose you are asked to find at what angle you throw the object so that it will cover the maximum distance. So you have to find the angle at which you have to throw the ball so that range would be maximum. So for r to be maximum, you know this sine, see, u is constant, g is constant. So sine theta, sine 2 theta has to be maximum, and sine 2 theta, the maximum value of sine 2 theta would be 1 only, and this will be maximum when this angle would be 90 degree. So 2 theta is 90 degree. So theta would be 45 degree. So if you throw the object at 45 degree with the horizontal, you will get the maximum range, and that would be equal to u square upon g. Remember this. Remember this.
So can you explain it again?
Yes. Suppose you are asked to find the angle at which you throw the ball so that the ball will cover up the maximum horizontal distance, means maximum range. So for range to be maximum, at what angle you should throw the object, right? So see, range is what? U square sine 2 theta upon g. So this range would be maximum when sine 2 theta would be 1. The maximum value of sine is 1. And sine takes maximum value when angle is pi by 2. So this 2 theta would be equal to pi by 2. So theta must be equal to pi by 4. So if you throw the ball at 45 degree with the horizontal, it will cover the maximum distance along x-axis, right?
So
Understood?
it's 2 into pi by 2.
Yes, yes. 2 theta is pi by 2, na? So if you divide by 2,
Oh,
na, you will get
like
theta as
that.
pi by 4.
Okay. Okay, okay. Like the whole thing inside is pi by 2. Okay.
Yes, whole thing inside should be pi by 2.
Okay, okay.
And the maximum value of range is u square by g.
So for all cases or for a general case?
For all cases.
Okay.
And for all cases means like, when there is no air resistance or there is no external force. When only gravity works. In that case only. If situation will change, like, some air is blowing or something, air is applying some force in horizontal direction or some at some angle, in that case, the range will be different. So theta will be different. I'll tell you that thing later. Done? Everyone done?
Yes.
No, remember one thing. Note. At complementary angle, range will be same. Did you understand this? There are two situations. You throw the ball at some angle theta with the horizontal. In other case, if I throw the ball with the same speed, has to be same at 90 minus theta. So these two are complementary angle. So if you throw the ball at complementary angles, range will be same. This is very important point. See, what is the formula of range? R equal to 2u square sine theta into cos theta, or like you can also write like this. U square sine 2 theta upon g. Theta is the angle made with horizontal. In this case, if you write, let's say this is r dash. U square, speed has to be same, sine 2. Theta was the angle with horizontal. What is the angle here? 90 minus theta. So 90 minus theta upon g. So this would be sine 180 minus 2 theta. 180 minus 2 theta. And what is the value of sine 180 minus theta? Sine theta only. So this is u square sine 2 theta upon g. This is very important point. So if you throw any ball or any object at complementary angles, range will come out to be same. Like if I give you an example, suppose you throw a ball here from here with some speed, u at some angle, suppose theta. So it will follow this path and come over here, right? But suppose there is a long wall. Its height is more than its maximum height. Then what will you do? Then you will throw this. You can also throw this projectile at its complementary angle. It may cross the wall and it will strike the same point. So range in both the cases will be same. But by providing this angle, you can cross this wall. That depends on calculation, right? So in both the cases, range will come out to be same. Remember this. Done, everyone?
Yes, sir.
Okay. So now one question for you all. You have to solve this. A ball is projected with initial velocity 10I plus 20J meter per second. Find maximum height, H means maximum height. Second, time of flight. Third, speed at highest point. And fourth, range. Tell me, solve it. I give you 2 minutes. That is enough.
So what is the actual answer?
Let me write the answer now.
No, sir, just for me to check if mine was correct for the
Yeah,
first
yeah.
one.
Maximum height, right?
Yeah.
So maximum height is 20 meter. Time of flight is 4 seconds. Range you can find, na? How much? Um, you can. So did your answer matched or not?
So what was the range?
I'll find 1 minute.
Sir, I'm not getting the answer.
10 into 440. And speed at highest point would be, I have to find. So these three matched or not? Shaina, these three answers matched or not?
So I did the range, sir, until now. I solved for the range.
The range 40 matched or not?
No, sir, I got 50.
Okay. 50. Acha. Ayushi and Prisha, did you get the answer?
No, sir.
Acha, theek hai. Okay, wait. See, what it is saying. Initial velocity is this much, right? Now you see. So U is 10I plus 20J. So what is initial component along x-axis? That is 10. And what is initial component along y-axis? That is 20. Understood or not? Now see,
So you're
this is
solving
x.
for height, right?
I'll solve. So
Okay.
did you understand this thing? There are two components of initial velocity, one along x-axis and one along y-axis. So ux would be 10 and ui would be 20. So the velocity is given in vector quantity. This is u and this is uy, that is 20, and this is ux, this is 10. You can find this angle as well. How? Like this vector addition. This is u, and this angle you can find. Tan theta is this upon this. So if this is ui, so this will also be ui. That is 20 upon ux 10. So tan theta is 2. Did you understand?
Yes, sir, I got it.
Okay, ठीक है. You
Yes.
got this. Okay, fine. Now, see, what is time of flight? 2u sine theta upon g. What is this u sine theta? This is initial component of y component of initial velocity. That is 2uy upon g. What is uy? 20. So this is time of flight is 4. And what is h max? H is u square
For the
sine square
height,
theta. See na, u square sine square theta upon 2g. So you can write this as u sine theta square upon 2g. U sine theta is what? Uy na.
yeah,
That's why I also wrote it down that time.
yeah,
Uy. And Uy is 20. So square is 400 on 2
yeah,
into 10.
yeah.
That is 20 meter.
Yes, sir.
So H is fine. Now what is the range? You know that range is what? U cos theta into t, time of flight. And what is this U cos theta? It was Ux into t. What is Ux? That is 10. And what is time of flight? That is 4. So 40. And what is the speed at highest point? Speed at highest point is what? U cos theta. Horizontal, at highest point, there will be no velocity along y direction. So only horizontal direction. So U cos theta. And what is this? Ux. And what is this? 10. Simple, no? Simple, no?
Yeah.
So speed at highest point, I didn't understand.
Speed, see, at highest point, at this highest point, there won't be any velocity in y direction.
Yes.
So there will be there will be only horizontal velocity.
Yes.
So this will be the speed. No? Speed means
Oh,
velocity at highest
yes.
point would be velocity along x-axis, that is u cos theta I, plus velocity along y direction, that is 0. So speed is magnitude of this vector, and that would be u cos theta only. That is
Yes.
ux. Simple. Now I'll give you a good question from Erodo.
So, sir, the answers are 20 meters, 4 seconds, and 10 meters.
Right.
Okay.
All done, Prisha? Are you getting?
Yes, sir. Yes, sir.
Fine. Let me know once done. IFC is done. Prisha is done. China is done. Fine. One good question from Erodo. You must try first. Then I'll tell you. Think.
Sir,
Tell me.
is it A? Because at Q, the velocity is vertical, which is the vertical component, V sine theta.
No, madam. It will take time now. Just take some time. I'm giving you 5 minutes. Think. And see, this is multiple choice question. You can see. In option A and B, it is asking about velocity of the particle at Q. And in option C and D, it is also asking about the time of flight from P to Q. Take 5 minutes. First, you let me know if any one of you are getting or not. If you're not getting that, then there is no sense of giving that. If you're getting, if you're understanding the process and how do you proceed, then I'll give you a few minutes.
Sir, 2 minutes.
That's it, 2 minutes.
So it makes sense to say V by G sine theta, but like that's not an option. So I'm assuming it's the closest, which is
Now,
inverse.
now I'll tell you. I'll tell you. See, everyone see what it is saying. It is saying that a particle is projected from a point P. Suppose this point is P. From where? From the point it is projected, you can assume that point as origin. With the velocity V at an angle theta with the horizontal. So, this angle is theta. So, it will follow this path, parabolic path. This is projectile. At certain point Q, it moves at right angles to its initial direction. Suppose at this point Q, it moves in the perpendicular direction. So, initial direction was what? This one. At this point, its motion will be like this. It is saying that this is 90 degree. So at Q, the direction of motion is like this. It is saying that at Q, this will move in the perpendicular direction to the initial direction. So initial direction was this thing. And at Q, it is like this. So this angle is 90 degree. So now you have to find the velocity at Q. At certain point, at a certain point Q, it moves at right angle to its initial direction. Then, so find the velocity at Q. Suppose the velocity at Q is V dash. So this V dash would be a vector quantity V dash xi plus V dash yj. So at this point also, suppose at this point also, this will have some x component and some y component. Now you can find x component is like this. Vx dash would be what? Initial velocity along x-axis plus acceleration along x-axis into time. And this Vy dash would be initial velocity along y-axis plus acceleration along y-axis into t, that is j. V equal to u plus at, correct? And what was Vx? That would be Vx would be V cos theta. And what would be Vy? That would be V sine theta. Put over here. Vx would be V cos theta. And there is no acceleration along x-axis. So this is 0. So this is simple. I plus what is Vy? That is V sine theta. And what is the acceleration along y-axis? Suppose you take this as positive. So downward would be negative. So acceleration x downward. So Ay would be minus g into t I. So this is the velocity at point Q, suppose. Understood? Till here?
Yes.
Yes.
Okay. So this is the vector quantity. And what is initial velocity? That is, let's say, velocity at point P. That would be V cos theta I plus V sin theta j. Now it is saying that velocity at point P and velocity at point Q, they are perpendicular to each other. Now you see, if when two vectors are perpendicular, what property you apply? Suppose vector A and vector B are perpendicular to each other, so dot product should be 0. You must have
Yes.
studied in vector. So now you have to do Vp dot Vq equal to 0 because these two vectors are perpendicular to each other. So you have to take dot product as 0. Take V cos theta I plus V sin theta minus GT J dot V cos theta I plus V sin theta J equal to 0. Then how do you take a dot product? You multiply x component of one vector to x component of other vector and y component of one vector to y component of other vector. So V cos theta into V cos theta would be V square cos square theta and z component would be V sin theta of this vector and z component of this. Y component of this. V sin theta. This is 0. So V square cos square theta plus this into this V square sin square theta minus GT into V sin theta. You can see here V square, you can take common, sin square theta plus cos square theta would be 1. So V square equal to, this will go right side, GT V sin theta. V gone. So T you can say V upon G sin theta. So after projection, it will take this much time. When it's when velocity of this particle will be perpendicular to the initial direction. So after this much time, so you can match one of your option V by G sin theta. V by G sin theta is V by G cosec theta. So C is correct answer. C is correct answer. Now you have to find velocity at point Q. So you have to put this time.
So
In-
can you scroll down a little bit once? I want to see the last step. So is that V square? What? Oh yeah, okay.
V square cos square theta plus V square sin square theta minus GT V sin theta.
So can you explain the last step again? After V squared cos square theta.
From here,
Yeah.
see, you know one identity in trigonometry you must have studied, sin square theta plus cos square theta is 1, right?
Yeah.
So you take a V square common. So V square will, if you take common, you will have cos square theta plus sin square theta. That is 1.
Okay. Okay. V square.
So this is V square minus this term GTV
Oh.
sin theta equal to 0. One term you take it to right side. So this will come here. V cancel and then T equal to V by G sin theta.
Okay, got it, sir.
Now you have to find the velocity at point Q. So what you have to do? You have to put this time. You have to put this time in this equation so that you will get the velocity at point Q. So VQ would be V cos theta is fine. There is no T term here. Plus V sin theta or minus G into T. T here. What is T? V by G sin theta. V by G sin theta. बोलो अभी रुको बाद में करते हैं. G gone. So this is V cos theta I plus V common. So and if we take LCM, sin theta into sin theta, sin square theta minus 1 upon sin square theta J. So this will become, shall I erase this part? So this VQ would be V cos theta I. Take minus sin common out. So this would be 1 minus sin square theta. That would be cos square theta. So cos square theta upon sin theta and Vj. Now you take the modulus of this. So that would be a square root of V square of this component plus square of this component. That would be cos square theta upon sin theta to the power 2 into V square. You can see you can take V square out will come as V, cos square out will come as cos theta, and now 1 plus cos square theta upon sin square theta. Take LCM, you will get sin square theta plus cos square theta upon this sign will come out. This is one identity. So V cot theta. So B is the correct answer. Tell me, you understood or not?
Sir, after that, the product of the two vectors will be 0 vector. Sir, after that, I was not able to write the steps.
So why did you tell me? So see, so you took the dot product, right?
Yes.
You multiply this. Do you know how to take the dot product?
Yes.
Multiply that and you find the time. You will get time. Acha, ruko. Let me write again. See. Oh, no, no, no.
Oh, yeah, this one only.
Acha, okay. This one only?
Yes, sir. Just 1 minute. Sir, could you please scroll up?
Mm-hmm. Prisa and Saina, did you understand the concept that I told you?
Yes, I got it.
Yes.
In coaching, I believe like they must not be making you to do this kind of problem, right? In any of the coaching. Do they give you this such kind of problem in class?
No, sir. But like, so the thing is, we have something called the Avanti module. So we have questions that are difficult in that, but in class we
Yeah.
don't do. But this is good.
Huh. In a booklet it is given. In all the coachings, in booklet it is given, but nobody will help you. Then how would you solve it, right?
Yeah, yeah.
Even I was teaching in big coaching sometime back in IT and space in Mumbai.
Done, sir.
ऑल डन ना प्रिसा समझ में आ रहा है बेटा आपको
Yes.
विद्यालंकार में करवाया कभी ऐसा क्वेश्चन लोगों ने
Sir, actually, like we have similar
Sir,
sums
have
in
you
the
heard
booklet.
about have you ever heard about Kabir Bajaj in Vidyalankar? Kabir Bajaj, he was topper.
To
Last year
also,
I taught him. Yeah, last year I taught him.
so
जानते
we
हो
have
सुना है
similar questions in the booklet, but we sometimes solve these questions if sir
मतलब
gets time.
frequently class में teacher do not discuss this kind of question generally. हम्म, चलो इसको हो गया होगा तो मुझे बताओ Done or not?
Done.
Chalo. Let's see another question. Another good question. See. This is the question and this is the answer given. Solve it. And if you do not understand, let you know. Giving you 5 minutes.
So I got the part A and B, the first part. B, second part, I don't think I understand.
I'll explain that. It is just the vector thing.
Okay.
I'll tell. Ayushi and Prisha.
Yes, sir. Got it.
Prisha, you got it?
Sir, I got the first and the second, this first part. The second part.
Okay. Let me also start. See, it is saying that a small body is thrown at an angle to the horizontal with initial velocity. See, angle is not given. There is no term of angle here in answer. Angle is not given. See, you cannot assume theta. If you assume, you have to replace that. So suppose this is horizontal x, y. At some angle, this is projected theta. This is given as v naught. So the displacement of the body as a function of time. This is the parabolic path it will follow. See, it is asking about displacement. Do you understand displacement? At any time, suppose this object is over here. At any point, see this is P and this is
It'll be the range.
no. Displacement. It is like no final position when it's initial position. So this should be the displacement PQ.
But sir, for the entire journey, it's the range. For the whole
But it is
journey.
asking as a function of time.
Okay.
Yeah, I know for entire journey it is range, but there is no nowhere there is no formula of range. You have to find displacement as a function of time. So at
Okay.
any certain time. So this is the range PQ. This is your range displacement. So you have to find this, right? As displacement you have to find.
Yeah.
See, how would you find this? See, just make a table. Ux is what? V naught cos theta. Uy is what? V naught sin theta. Ax is what? 0. Ay is what? Minus z. Suppose I take upward as positive and downward as negative. Now I have to find displacement. So this displacement would be what? Displacement along x-axis I plus displacement along y-axis j. I will find displacement along x-axis. That would be ux into t plus half ax into t square. But there is no ax. 0 it is. So this would be v naught cos theta into some time. And same thing over here. Sy equal to uyt plus half ayt square. Stop me if you do not understand. Uy would be what? V naught sin theta into t, or ay is minus z. So minus half g t square. Put over here. Sx is what? V naught cos theta t I plus sy is what? V naught sin theta t minus half gt square j. See, V naught cos theta t I plus V naught sin theta t j. This and this you club it minus half g t square j. Now you can see this thing. Take V naught t common. V naught do not take t common. V naught cos theta, take t common only. V naught cos theta I plus V naught sin theta j into t plus half minus j minus g j t square. Now can we write this complete thing as V naught vector? Yes, we can write na. V naught can be written as V naught is any vector can be written as any vector A can be written as its x component I plus y component j. Ax is what? V naught cos theta I plus V naught sin theta j. So this would be the complete V naught vector into t plus half minus jj minus gj. It can be written as g vector. So vector is a quantity which is having two things, magnitude as well as direction. So this vector g vector would be having magnitude as g and direction as minus j, downward direction, and then t square. Did you understand? I hope you must not have done in this way, but now did you understand?
Yeah.
Note it down.
Yes.
Huh. Note it down. Initially, for the couple of questions, now you make your habit like you make this table and write all the components along x-axis and y-axis. And later on, when we'll have good practice, then you can ignore that table. You can directly do. But in starting, for the first couple of few questions, you do this.
Okay, sir.
So for almost all the questions, we use the vector form. I
No,
guess.
in this question, because an answer is given in vector form, that's why we did it.
Okay.
And you can also see, you have assumed theta, that is angle of projection, but there is no term of theta in the answer, so you have to remove that. Acha, Prisha is done. So I'm now waiting for China and Aishi. Let me know once done. There is no hurry. Acha, all done. Fine. Let's go ahead then. Now, second part. See, in second part, it is asking two things. Mean velocity vector averaged over the first t second. First t second. I mean, during 0 to t second, any t second. And then over the total time of motion. So see, velocity vector, average velocity vector. Average velocity vector is what? Displacement that in this case we are representing by r. So no problem. We'll write r. Displacement upon total time. So displacement is this much. Just now we proved v naught vector. So see in aerodome, they are they have different way to write a vector. Bold in bold. If they write in bold, it means it is vector quantity. So v naught t plus half g t square upon t. T cancel. V naught vector plus half g t. Matched? Yes, matched. Note it down.
Done, sir.
Trisha? Done. Okay, now for third part, see, this is very good. It is asking about the average velocity during the total time of motion, right? So in this case, we'll simply give V average equal to V naught plus half G T. So for complete journey, this T would be capital T, time of flight. Now, what we'll do is, what is the value of time of flight? We'll put 2u sine theta. So u is V naught. V naught 2 V naught sine theta upon G. We have V naught, we have G, but we do not have theta. So we have to replace theta. Huh. We'll replace, don't worry. V naught plus G into V naught upon G into sine theta. Now do one thing. See, this is your G and this is your V naught.
So G doesn't get cancelled out because it's a vector.
I'll cancel. This is vector quantity. We have to give one extra minus sign. I'll cancel. Don't worry.
Okay.
So see, this is initial velocity V naught and this is G. So what is the angle between V naught? Because now we have answer in V naught and G. So what is the angle between V naught and G? That is 90 plus theta, isn't it? This angle is 90 and this is theta, right? Now what we'll do is this is dot product. So V naught vector dot G. That would be V naught magnitude of G into cos of angle between these two vectors. That is 90 plus theta. 90 plus theta. So this would be minus V naught G sine theta. We'll replace this sine theta by V naught dot G upon minus V naught into G. Replace here. V naught plus G upon G. This is not dot. This is scalar quantity only. V naught and sine theta would be minus V naught dot G. This is vector dot product upon V naught into G. C.
So why did you multiply V naught into G?
Well, because no, we have to replace beta theta, na, because we do not have theta known. This is parameter. In question, nowhere it is mentioned theta. And even in the answer, theta is not mentioned. And we have considered this angle of projection theta. So we have to replace in the end. Na?
Oh,
So we use this method because we can see that there is dot product between V naught and G. So this is how this is very important step. So now see V naught, this minus will come out. So minus this V dot G and G is here. See G vector is over here. That's why I did not cancel. And V naught dot G is also here. You can see over here upon G into G square matched. Understood?
so sir, after getting the value of a sign, you have to substitute the sign into the equation that we got earlier.
Correct. Prisha is done. Prisha, समझ रहे हो ना बढ़िया से?
Yes.
Shaina, did you understand what I just told to Prisha?
So, yeah.
Yeah, I had a friend, and Jyotirmay, she was from Hyderabad when I was in BTech. She had the same problem in the first year.
Oh. So I can understand and all. It's just that I won't speak fluently.
Okay. You understand? So did you
Yeah.
understand what I just told Prisha?
Yeah.
समझा अच्छे से? अच्छा,
Yeah.
ठीक है. Okay, fine. So
So
IoT is done. Shaina
just
done.
1 minute, sir. I'm just writing down. Yes, sir. Done.
Okay, now I'll give you one very simple question for you. You have to solve. See. Very simple, very simple. See. This is x-axis. This is the y-axis. A ball is projected from this point at some angle. Let's say this is 53 degree with some initial velocity 100, initial speed, let's call it 100 meter per second. So we have to find, this will follow this parabolic path, projectile motion. So now we have to find when ball is moving at an angle of 37 degree with horizontal, then find first speed, second time, ठीक है कि when it will how much time it will take to go there, and height. Drives. Giving you 5 seconds. Oh, for 5 minutes, sorry.
Sir, can we leave it in terms of sign?
No,
Will-
madam. No,
Okay.
no, you have to use sine 37, sine 53. You don't know?
I guess
You
I
don't
do.
remember? You don't remember?
No.
Let me tell you a very short trick for that. There is a trick to remember this. See, just draw a right angle. Just draw a right angle. Take this side as 5. Any smaller, suppose this is smaller side. So 3 and this is 4.
Oh.
You can take this 3 and this 4, no problem. So suppose assuming this is a smaller side. So 3. So this angle would be 90 degree. And smaller side means opposite angle should be smaller. So this angle would be 37 and bigger would be 53.
Oh, okay.
Now apply. This is the trick. You have remember, right?
Okay, thank you, sir.
Okay. What's up?
So, second and third, I think I got answers, but like first one, speed of
How much
like
time you got?
the time I got 20.
No, madam. 20 sec. No, no, no. That's incorrect.
Sir, is it 12?
It's incorrect. Ayushi and Prisha, any luck?
Sir, 80 meter per second, 16 second, and 320 meter.
No.
Sir, is it 12 seconds?
No.
So, what is the height? Is it 50 meters?
Height is where it is I have to calculate, I guess. It would be, no. It would be much larger, I guess. No, it is not given. I'll calculate. Krisha, let me calculate. Krisha, did you solve?
Sir, I'm getting time as 12 seconds.
How much?
12 seconds.
12 seconds. No. See, let me explain you. See, when ball is moving at an angle of 37 degree with horizontal. Suppose at some point, this ball will be moving at some angle. This angle is with horizontal is 37 degree. Suppose the speed is v. So it will have two component, v cos 37, v sin 37. Correct? You know sin 37 how much? 3 by 5. Cos 37, 4 by 5. So this would be 3v by 5. This would be 4v by 5. Break this also into components. This velocity will be, ux would be 100 cos 53. And you can see cos 53 is how much? 3 by 5. So this would be 75 meter per second. And uy would be 100 sin 53. Sin 53 is how much? 4 by 5. Oh, 1 minute. Sorry. This is 60 meter per second, and this is 80 meter per second. Correct? Yes. Now, you know that in projectile, horizontal velocity does not change because there is only gravity, right? There is no external force. So horizontal velocity will always remain constant. So this 4v by 5 must be equal to 60 meter per second. So v equal to 60 multiplied by 5 upon 4. 75 meter per second. Understood or not? Let me know if you have any doubt.
Sir, actually, I don't know.
Sorry?
Sir, I had a doubt. When do we like use the formula that you gave?
When do we use which formula?
Sir, am I audible now?
I can hear you, but their voice is not that clear. But tell me again. I'll try to understand.
Sir, when do we use the formula that you gave? Speed is equal to like u cos theta and u sin theta
Every
in the
time,
horizontal.
every time. See, do one thing. Every time, whatever is the initial velocity, break it down into two components, along x and along y. And suppose at any point you have to find the velocity, yes, speed. Assume that the velocity is v at any point, like we did here. And if angle is not given, you have to assume some angle theta. Again, break it down into two components, along horizontal, along vertical. And you know that in projectile, there is no force acting along horizontal direction. There is only one force, that is gravity, acting along y-axis. So there will be, so acceleration will be along y-axis only. There won't be any acceleration along horizontal direction. So if there is no acceleration, v equal to u plus at. If a is 0, so v and u will remain always same. So velocity does not change in projectile motion in horizontal direction unless until any external force is applied. Samjha?
Sir, so here for finding like the speed in the horizontal direction, I directly used u like v cos theta, where v is 100 and cos 37 is 4 by 5. So there I'm getting
No. It is, see, at 53, you projected the object. Now, at certain point, it will be at 37 degree at the horizontal. That time, this speed will be different, now. This
yes.
100 meter per second, 100 meter per second was the initial velocity. Now it will go up. Gravity works on the ball. So speed will keeps on decreasing now with time. And at maximum distance, at maximum height, it will have only horizontal direction velocity, right?
Yes.
So first you have to find the speed. Okay. Note it down.
So will time be 9 seconds?
No, man.
No.
I'm coming. Wait.
No, I was just
Note it
trying.
down. No, it's all right. It's all right. So everyone have SC Burma.
Yeah.
I'll I'll give you task for homework. I'll WhatsApp.
So does this trick work for all angles? It should, right? All.
Yes, yes, yes. It's a general concept. It's a
Okay.
general concept. There is no trick here.
Yeah, yeah.
Done? Written?
Yes, sir.
Okay.
Sir, I
Everyone
have one
written?
doubt.
Yes.
Sir, in the answer, why are we writing 75 meter per second but not 60 meter per second?
Ma'am, 60 meter per second was initial velocity along x-axis at certain point. See, 60 meter is when it is making 53-degree angle with horizontal. But we have to find the
Yes,
speed when it is making 37-degree with the horizontal. Understood?
yes, sir. Okay.
चलो ठीक है okay fine अभी let's see second point time and then height is what this distance at any time suppose this is the distance height right okay how do you find time now you can see you have found the speed v so let's put here 3 by 5 into v is speed is at this point speed is 75 meter per second so 15 this is 45 meter per second now you can see that initial speed was see we have to find height so that is along y-axis only and as per the Galileo statement we can see that motion along two mutually perpendicular direction is totally independent of each other so now we are thinking about the motion along y direction only because we have to find displacement along y-axis only right so now displacement along y-axis would be yeah vy equal to uy plus ay into t because you know that at certain height we have to find at this height how much time it will take so at this point we can see that we have this velocity along y-axis right so along y-axis yes so this is 45 and uy was 80 and the acceleration was negative because we have taken upward is positive and downward is negative. So this is minus g. G we can take 10. This is t. So 10t equal to 80 minus 45. That is 35. So time taken is 3.5 seconds. Understood? Bolo.
Yes.
Shaina and Prisa both understood?
Yeah,
Or
yeah.
have it
Done.
done?
Yeah.
Prisa done, na?
Yes.
Perfect. Now third part is height. Height means displacement along y-axis. So displacement along y-axis equal to initial velocity along y-axis into t plus half acceleration along y-axis into t square. So displacement along y-axis is your height. Uy that is 80 into time. How much time it took? 3.5 seconds. Minus half 10 into 3.5 seconds whole square. Solve it. You will get the answer.
So what is that? Y equals?
80 into 3.5 uy into t.
Oh, okay.
80 into 3.5 minus half gt square. बोलो सुनील 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 वीडियो बाहर दे
So it's a very big number. What is the answer, sir? Final answer.
Oh, wait 1 minute. Let me use calculator. Or you can apply another method. This is going to be little complex, na? Apply another method. See, you know the vertical component of the velocity. Initial component of the velocity, you have to find displacement. Apply this. V square equal to u square plus 2a along y into s. Means that is displacement along y axis y. Now find y would be vy square minus us squared upon 2ay. So this is vy square is how much? This 45. 45 square minus ui 80 square upon 2 into ay is what? Minus g minus 10. Now solve. This is going to be 80 square minus 45 square upon 20. Now tell me a square minus b square. That is a plus b. That is 125. A minus b 35. It's simple now, right? 5 4 ja 5 7 ja. So this is like 125 into 7 upon 4. Much easier. Yeah. Both will give you same answer, but calculation may be different. If you want to calculate it roughly, na, assume this is not 125, this is 124. So you
Sir,
can cancel this. Huh?
is it 218.75?
Something like that. Yes, yes, something like that. No, okay, okay, fine. Now you can observe one more thing over here. See, this point, at this point, it is making some angle 37 degree, right? So if you draw a horizontal line, at this point again, it will make the same angle, 37 degree. Understood? And then you have to find, suppose so this ball will come at the same height at two different times. Suppose this is y, so this is also y. You'll calculate this and you'll get some value, right? So at two different times, it will come at the same height. So now you have to find both the times. You have to find this time as well. Suppose from here to here, it has taken some t1 second, 3.5 second. Now from here to here, it will take some other time, t2. You have to find, if you have to find that thing, how do you find? Simple, very simple, very simple. See, at same horizontal level, it will make same angle, 37 up, 37 down, right? So here, it will have two components. Again, if this is 45 vertically up, then it will have 45 vertically down, 45 vertically up, then 45 vertically down. Do you understand that?
Yes, sir.
So for this point, you can apply this formula. Vy equal to ui plus ay into t2. So at this point, see, at this point, velocity was, speed was plus 45. But for this point, speed would be how much? Minus 45. And ui was, will be same, 80. This is minus 10 into t2. See, 10 t2, this will come here, 125. So t2 would be 12.5 seconds. So at 3.5 seconds and at 12.5 seconds, at two different times, the ball will come at the same level. We'll do more questions in next class. So that's it for today. I'll send you the question number on WhatsApp. You can do your homework.
Sir, could you please send the previous homework also in physics?
Sorry,
The previous homework?
previous homework. Okay, we'll discuss
No, sir.
next
In
class.
physics, could you please send the numbers again?
Okay, fine. Okay, I'll send you.
Oh, thank you, sir.
Okay, see you. If done, then you can leave the meeting.
Thank you, sir. Bye, sir.
Bye bye.
Thank you, sir. Bye.
Thank you.